In every corner of our planet, from the densest jungles to the most arid deserts, there is a constant unseen conversation. It's a symphony of calls, cries, and songs that tells the story of existence itself. For millennia, these sounds have been a mystery to most, a language understood only by the creatures who speak it. But now, a remarkable change is underway. We're beginning to listen, not just with our ears, but with a new kind of intelligence, one born of human ingenuity. This is the world of bioacoustics, where technology is allowing us to tune into the hidden dialogues of the natural world. The challenge of understanding this global orchestra is immense. The sheer diversity of sounds, the subtlety of their variations, and the vastness of the habitats they fill have long kept their secrets guarded. Conservationists and scientists have spent lifetimes trying to decipher these calls, often with limited success, but the tide is turning. Artificial intelligence, a tool of immense power and potential, is now being directed towards this vital work. It's helping us to monitor the health of ecosystems, track elusive species, and protect those on the brink, all by simply listening. In this journey, we'll explore the extraordinary AI tools that are translating the languages of the wild. We'll see how a simple recording can reveal the presence of a rare bird, how patterns in sound can signal a thriving habitat or even warn of its decline. This is more than just technology. It's a new bridge between our world and theirs. A bridge that offers hope, understanding, and a deeper connection to the intricate, beautiful, and fragile web of life that surrounds us all. Imagine walking through a forest, the air filled with a chorus of birdsong. Each trill and chirp is a unique signature, a declaration of territory, a call to a mate, or a warning of danger. For most of us, it's a beautiful but indecipherable melody. But what if you could understand it? This is the promise of BirdNet. Developed by the Cornell Lab of Ornithology and Chemnitz University of Technology, this remarkable tool uses a form of artificial intelligence known as a neural network. It's been trained on an immense library of bird sounds, contributed by citizen scientists and researchers from all over the world. The process is one of elegant simplicity for the user, yet immense complexity behind the scenes. An audio recording captured on a simple smartphone is uploaded to the system. The AI then analyzes the spectrogram, a visual representation of the sound, and compares the intricate patterns of frequency and time against its vast database. It searches for a match, sifting through thousands of possibilities in mere seconds. It's the digital equivalent of a master ornithologist, one with an encyclopedic memory of over 3,000 of the world's most common bird species. The implications are profound, not just for the curious amateur, but for global conservation efforts. By crowdsourcing data on such a massive scale, BirdNet is creating an ever-evolving map of avian populations. It can help track migration patterns in real time, detect the arrival of invasive species, or monitor the health of local bird communities. Each identification, each small piece of data contributed by a user, adds another note to this global composition, helping us to better understand and protect our feathered companions. To truly understand an ecosystem, one must be present, patient, and persistent. But the presence of a human can alter the very behaviors we wish to observe. Animals fall silent, retreat into the shadows. This is where the song meter developed by Wildlife Acoustics becomes an essential tool. It's not just a microphone, it's an autonomous, rugged listening post designed to endure the harshest conditions the natural world can offer. Deployed deep in rainforests, high in mountain ranges, or along remote coastlines, these devices can record for weeks or even months on end. They're the tireless sentinels of the scientific community, programmed to record at specific times, perhaps at dawn and dusk when activity is at its peak, or throughout the night to capture the calls of nocturnal creatures. They gather enormous quantities of acoustic data. The song meter captures everything, from the low-frequency rumbles of elephants to the ultrasonic clicks of bats far beyond the range of human hearing. It provides an unfiltered, uninterrupted acoustic snapshot of an environment, revealing a level of detail that was previously unimaginable. This raw data is a treasure trove. When paired with analytical software, also powered by AI, it allows researchers to conduct comprehensive biodiversity surveys without ever disturbing the habitat. The AI can be trained to recognize the calls of specific target species, automatically scanning through thousands of hours of recordings to flag a single vital call. It's a powerful method for monitoring rare or elusive animals, providing concrete evidence of their presence and allowing for more accurate population estimates, which are critical for effective conservation strategies. There is a unique magic in the moment of discovery, the instant a name is put to a natural wonder. The Cornell Lab of Ornithology's Merlin Sound ID has harnessed this magic and placed it in the palm of your hand. While BirdNet analyses recordings after the fact, Merlin works in the here and now. It listens to the world around you in real time, its artificial intelligence engine working continuously to identify the birds singing nearby. It is like having a seasoned naturalist whispering in your ear, identifying each member of the avian choir as they perform. The technology is a marvel of efficiency. The app's AI runs directly on the smartphone, analyzing the live microphone feed. As a bird sings, its call is instantly converted into a scrolling spectrogram on the screen, and the AI suggests possible identifications, highlighting the most likely species. This immediacy transforms a simple walk into an interactive learning experience. It breaks down the barrier of the unknown, empowering anyone from a child in their backyard to a hiker on a new trail to connect with the bird life around them in a more meaningful and informed way. This real-time feedback loop does more than just satisfy curiosity. It fosters a deeper appreciation and understanding of biodiversity. By making bird identification accessible and engaging, Merlin Sound ID encourages a new generation of citizen scientists. It teaches users to listen more closely, to distinguish between different calls, and to recognize the complexity of their local soundscape. Each user becomes a potential data point, a potential steward of their environment, building a collective awareness that is fundamental to conservation. The sheer volume of data collected by devices like the Song Meter presents a monumental challenge. We are talking about terabytes of audio, thousands upon thousands of hours of recordings from projects all over the globe. How can a research team possibly manage, let alone analyze, such a deluge of information? The answer lies not on a single computer, but in the cloud. Arbimon, a platform developed by the non-profit Rainforest Connection, provides a powerful, web-based solution for this very problem. Arbimon, short for Automated Remote Biodiversity Monitoring Network, is a comprehensive ecosystem for acoustic data. Researchers can upload their vast audio libraries to the platform, where they are securely stored and organized, but it is much more than just a storage locker. It is an analytical powerhouse. The platform incorporates AI tools that allow scientists to create what are known as template matchers or recognizers for the calls of specific species. They can train the AI on known examples and then unleash it on their entire dataset. The system will then work tirelessly, scanning through years of recordings in a fraction of the time it would take a human. It can identify patterns, map species distribution over vast landscapes, and track changes in vocal activity over long periods. This cloud-based approach also fosters unprecedented collaboration. Scientists from different continents can access the same data, share AI models, and work together to answer some of the most pressing questions in conservation, creating a global, interconnected community dedicated to listening to the planet. While identifying individual species is crucial, the health of an ecosystem is often revealed in its overall sound. The field of ecoacoustics looks beyond single voices to analyze the entire soundscape. It considers the acoustic environment as a whole, a rich tapestry woven from the calls of animals, the sounds of the physical environment like wind and rain, and the noise created by human activity. Specialized analysis programs powered by AI are now allowing us to measure the richness and complexity of these soundscapes. These sophisticated software tools don't just look for one specific call. Instead, they compute what are known as acoustic indices. These are metrics that quantify the properties of the soundscape, such as its diversity, evenness, and amplitude over time. For example, a high acoustic complexity index might indicate a healthy, biodiverse habitat with many different species vocalizing across various frequencies. Conversely, a sudden drop in this index could be an early warning sign of environmental stress, such as pollution, deforestation, or the impact of climate change. This holistic approach provides a powerful diagnostic tool for the planet's health. By deploying recorders and analyzing the resulting ecoacoustic data, we can monitor the vital signs of an entire ecosystem. The AI helps us to see, or rather hear, the big picture. It can detect subtle long-term shifts in the environment that might otherwise go unnoticed until it is too late. It is a way of listening to the collective voice of nature, a voice that speaks volumes about its resilience, its fragility, and its urgent need for our protection. We have journeyed into a world of sound and silicon, where the ancient calls of the wild are being interpreted by the most modern of technologies. From the instantaneous identification of a garden bird to the long-term health monitoring of an entire rainforest, artificial intelligence is granting us an unprecedented ability to listen and to understand. These tools are more than just novelties. They are becoming indispensable allies in the critical mission to study, preserve, and restore the biodiversity of our planet. They are amplifying the voices of those who cannot speak for themselves. The power of this technology, however, is not confined to laboratories and remote research stations. Tools like BirdNet and Merlin Sound ID are accessible to everyone. They are an open invitation for you to step outside and engage with the natural world in a new and profound way, to transform a walk in the park into a voyage of discovery. By participating, you not only enrich your own experience, but you can also contribute valuable data to a global community of observers, helping to build a more complete picture of life on Earth. So I encourage you to try them. Download an app, take a walk, and simply listen. Pay attention to the symphony that is constantly playing around you. Each call you identify is a thread in the magnificent tapestry of life, a thread that you now have the ability to recognize and appreciate. In learning the language of our fellow creatures, we deepen our connection to them and strengthen our resolve to protect the shared home that we all depend upon. The future of the wild may just depend on how well we learn to listen.